I'm Tom Bizance, and this is Mr. Number's Pattern Play Math show. And today we are doing left-right multiplication magic math. And it really is magical. It's really fascinating. I think you'll enjoy it. It's based on a Vedic technique that basically uses specific numbers, but basically all the larger numbers, 5 through 9, work on the left side of the wheel, on the number wheel. And it also uses the 10 bonds, the numbers that add up to 10. So 9 and 1, 8 and 2, 7 and 3, 6 and 4, and 5 and 5. And so it works beautifully on a wheel. And that's what I'm going to show you today. So enjoy. Kids don't have any problem with, if you look at the number wheel, behind me, on the right side is like, 1 times 3 and 2 times 4, and those numbers are easy for kids to do.
Mm-hmm.
So it's the numbers actually that are on the left of the number wheel, and that are difficult for them. So 5, 6, 7, 8, 9, even 5 works for this method.
Okay.
And you can actually multiply numbers really easily and quickly. So kids who are, especially I'm thinking of like third graders who are just first learning multiplication,
Mm-hmm.
and fill in their times table with this.
How?
So how does this work? So we have some number wheels there, right?
Mm-hmm.
All right, so we're going to multiply. A couple numbers are on the left. What happens here? I've got some ink. We'll use this one right here. So Jill, give me a couple numbers from the left side of the 5 to 9.
8, 7.
8 and 7. Okay. So we circle 8 and 7 there. Okay.
Mm-hmm.
Now we draw a line right across. What are the two numbers over there?
2 and 3.
2 and 3. Good. I'm going to put a square on those. Now, it doesn't actually make any difference which way you go. Do a diagonal subtraction. So 8 minus 3 or 7 minus 2 gives you what number? Diagonal. So it's this way.
Oh, diagonal. Okay.
Yep. And they'll both give you the same number, which is
5.
5, right? 7 minus 2 is 5, and 8 minus 3 is 5. Okay, we put a big 5 up here, and then we just put a line just because that's the tens digits. Now, multiply those two square numbers on the right side.
2 times 3?
Yep.
Okay. 6.
That's easy. You just write that. And the answer, 7 times 8 is 56.
Okay.
Pretty mind-blowing, huh? Let's do another one. Somebody else Jill, pick out two numbers.
9 and 6.
9 and 6, okay? So I circle 9 and I circle 6. And I draw a line over to what two numbers?
1 and 4.
1 and 4. So I just put a square on those just to identify them. And then if you subtract diagonal, what do you get?
5.
5 both ways, right?
Yes.
There's our 5 there. And if you multiply the other side on the right, the two numbers on the right,
4.
4, 9 times 6 is 54.
Nice.
It's just, what's wonderful about patterns in numbers are patterns. And so patterns show up everywhere. And this is just one pattern that shows up, and it works for all numbers on the left.
All right. Now that I have a clue of what you're doing, what about 7 and 6? Can
7 and 6.
Those?
Okay.
Circle around 7, circle around 6.
Yep. And now go across. What two numbers?
6 goes to 4, 7 goes to 3.
Okay. So I put a square on those two numbers. And then your diagonal reaches what number? Your subtraction, diagonal subtraction.
3.
Good. And 7 minus 4 is also 3. So it doesn't make any difference which one you do.
Okay.
Now
So you
look
got
on the right
3.
side, your two square numbers. What's 3 times 4?
12.
12. So that's 1 10 and 2 ones. Add your 3 and 1 is 4 and 4 2.
Hmm.
Let's do another one. We'll pick 2 more numbers. They can be the same number too. Except for 5 and 5.
So if you saying this will work for 8 and 8?
Sure. Let's do 8 and 8. Let's do it down here. So we do 8 and we'll do another circle around 8. Okay.
Okay.
And then we do, what's the number across?
2.
Good. So it's going to be 2 with 2 squares around it. So it doesn't make any difference. So 8 minus 2 is
6.
6. That's your tens. And 2 times 2 is
4.
8 times 8 is 64. Okay, you're starting to believe. So 2 more numbers. Who wants to do it? Perry, you want to
All
do
right,
one?
let's do 9 and 7.
9 and 7.
Circle, circle.
Yep.
7. 9 goes to 1.
Yep.
Now, where do I draw the diagonal from?
Well, you've got 2 numbers on the left, 2 numbers on the right. So do it diagonal that way and that way.
9 to 3 and 1 to 7.
Yeah. So subtract.
7 minus 1 is 6.
Okay. So 6. That's our tens. And multiply the 2 numbers on the right, the little numbers.
Okay, 1 times 3.
Multiply those.
1 times 3 is 3.
Okay. And we write that's our ones. 63 is our answer.
Okay, but we can do this if we use any number from 5 to 9. How would we do it with 5 if we're doing like 9 and 5?
Okay, let's do 9 and 5. Okay, we circle 9 and we circle 5. 9 points to what number?
1
Okay, and 5 points to what number?
itself.
Okay, so 9 and 5. So actually subtract either one, 9 minus 5 or 5 minus 1. It works for either number.
Okay, so 4.
4, that's our tens. And then our 2 numbers on the right are 1 and 5.
5. Oh
1
my
times
God.
5 is 5. 9 times 5 is 45.
Okay,
It's magic, isn't it?
complete magic.
Complete magic. All right, let's try a couple more here. Double a number, 5 times a number, or any number 5 to 9 to 5 to 9. Those are the big numbers. Those are the ones kids struggle with.
9.
8 and 9. Okay, we circle 8, we circle 9. What do I do?
Put a box around 1
Yep,
and a box around 2.
yeah. Okay, subtract diagonally.
All right, so you got 7.
So yeah, it's going to be that way or that way, subtraction. So I got 7.
And then 1 times 2 is 2.
8 times 9 is 72. Is that true?
Oh, okay.
Grudgingly, yeah, somehow it works, right?
Somehow it works.
Somehow
Okay.
it works. All right, let's do another one.
8 and 5.
8 and 5. Circle 8, circle 5. What do we do on the right? Those are our left numbers.
Box around 2.
Box around 2 and
Box around 5.
okay.
All right, now subtract. So 8 minus 5 is 3.
Okay. And 5 minus 2 is also 3. So it doesn't make any difference which one you do.
And 2 times 5?
Yep.
10.
Okay. So you put a 1 over there and a 0 over there.
I got it. Okay.
You get 40.
Yep. I figured that one out. All right.
All right. Who wants to do the next one?
Okay, I'll do 6 times 6.
6 times 6. Okay. So we circle 6 and then we do a bigger circle around 6. And then what number is across?
4.
4. So we put a square and then a bigger square, just so we know what we're dealing with. And so it doesn't make any difference. 6 minus 4 is
2.
2.
2. Okay. And then 4 times 4, right?
Is 16.
16. So 1.
Oh,
Six.
okay.
My goodness.
So you're 6 and the 1. Okay.
Yep. And 6 times 6 is 36.
Okay, now I'm good.
6 and 8.
6 and 8. Let's do 6 and 8. Tell me how to do it.
Okay, I've got a circle around the 8 and a circle around the 6 and a
Yep.
box around 2 and a box around 4.
Good. Okay. And so subtract either way that way.
So so diagonally I subtract 4 from 8.
Yep. And you get,
4.
okay. And if you did 6 minus 2, you also get 4.
Okay, and then I do 2 times 4.
Yep. Is
48.
48 is your answer.
Okay, I got that one.
Okay. Belief is starting to happen here.
We haven't done 7 times 5.
All right, let's do 7 times 5. Tell me how to do it.
Okay, so we're going to circle the 7
Yep.
and the 5.
Okay.
And we're going to go across from 7 to the 3. That's going to be a box.
Okay.
And then we'll put a square around 5 as well.
Okay.
We have to diagonally go to 7 and 5.
Yep.
And 5 to 3.
Yep. And what are both those come to the same answer, which is what?
That's going to be 2.
Okay. That's our tens.
And then multiply 5 times 3.
Okay.
And then that's going to be,
Okay.
that would be 35. Okay.
And there it is.
35. Okay.
I mean, one nice thing about it is it helps kids really clarify the ones and tens digits. And you could actually use 2 number wheels on the side, one for one for the tens and one for the ones if you want to.
Okay, well, I've been working with the 6-year-old on dynamic addition with regrouping, which is why I'm
Yeah.
thinking in place value right now.
Yeah, exactly. And it's so crucial for kids to understand place value. So this
Yeah.
is a wonderful way to do it.
All right. I got you on this one. I'll have to do it, but I was able to print my number wheels, so I got them all filled out.
Great. Great.
Use 2 separate number wheels to explain this to a child that hasn't grasped the concept to do it
Okay.
on one. Is that right?
So let's do that. All right. So we got 2 number wheels. So you're saying one for the tens digit and one's for the ones?
Yes, that's what I was thinking. That's what I'm going to do.
Okay. So let's actually, we'll set up the problem with 1 and then we'll use the other 2 to get our result. So go ahead and give me two numbers.
6 times 5.
6 times 5. Good. Okay, so what do we do first?
We're going to circle the 6 and the 5.
Okay, good. Now what do we do?
Then we're going to put our corresponding boxes on the numbers across, which is 4 and 5.
Yep, okay.
So 6 and 5.
So 6 and 5 or 5 and 4.
Okay. I've already jumped ahead. That's why I got messed up.
Okay,
6 to 5 and 5 to 4. That's going to be 1.
okay. So now that's our tens. So we put a 1 around the tens. Now, what are our two numbers on the right? The two with squares.
That's going to be 5 and 4.
Okay. And
Multiply those at 20.
that's 20. So if we're going to do that, if this is going to be the ones, and this is going to be the tens, then we're going to put a 0 here, and we're going to put, actually, we said 20, right? 5 times 4 is 20. So we're going to do 2 plus 1, 2 there plus 1 there. And actually, if you run your 2 plus 1 and you do your diagonal lines, it's going to point right down to 3. Or you can just do 1 plus 2 is 3. You see that?
Yes, I see it.
And then 0 there. So we go back here and we say 6 times 5 is 30. Or 110 and 2 tens.
How to do it now? Yes.
Or 110 and 2 tens. So it's kind of neat because then you're really playing with the tens, and the ones separately with that. So that might be an easier way. I'm trying. I mean, I literally just came up with this the other day, and so I'm trying to figure out the best way to explain it. So maybe using 3 number wheels might be the best way to do it. Now this is kind of planned, but what it's revealing is the deep patterns in numbers, because this works for all numbers. So Jack, give us another one, even double numbers or whatever you want. Give us another one here.
7 and 9.
Okay, 7 and 9. Somebody want to talk them through it?
Mm.
Draw a line from the 9 to the 1 and the 7 to the 3.
Okay.
And you're
These
going
are to make tens. And then what do we do with those two?
put a square around them.
Put a square around them? Okay.
Around the 1 and the 3. Okay.
Then what do we do?
Subtract 9 from 3 or 7 from 1.
And they both give you what answer?
6.
6. So we'll, in our tens over here, we've got 6 tens.
And you multiply 3 times 1 is 3.
So you multiply your two squares, your two little numbers, and that gives you 3. And your answer
63.
is 7 times 9 is 63. Isn't that mind-blowing?
Yep.
I mean, it's really pretty incredible.
How did you happen to I mean, are you at the point now where you see patterns because you do patterns? I mean, how do you come across this?
I'm always looking at patterns, and every time I see something, I just kind of go, And I saw this one as a Vedic thing where they just go to the number that adds up to 10. And they're talking about these numbers work and these numbers don't. Well, it works out that the numbers they're talking about are all the numbers 5 to 9 it works for, which are all on the left side of the number wheel. And they're also talking about the units that add up to 10. So those are numbers right across. So you can literally see, how it all works.
I was saying 8 and 7.
8 and 7, okay? 8 and 7. So what do?
We go to the numbers across from it and put squares.
Okay, put squares on those numbers.
which would be 2 and 3.
Yep. And so diagonally subtract.
Diagonally subtract, so. let's
So
do
8
5.
minus 3 or 7 minus 2,
Yep. And both of them give you what number?
5.
5. That's our tens.
And 2 times 3. Got
Our
it.
two little numbers, our 2 times 3 is 6. So
Okay.
8 times 7 is 56.
I actually got it this time. That's scary.
Well, if you just play with it enough, all of a sudden it makes more sense because you have to deal with the words, and words get in the way. But if you actually look at visually, it's pretty easy.
Okay.
So somebody else want to give a problem? Any numbers 5 to 9?
Well, let's try 9 and 6.
9 and 6. Talk me through it.
All right, circle 9 and 6.
Yep.
Go put a box around 1 and 4.
Okay.
All right, diagonally 9 to 4, 9 minus 4, or 6 minus 1 will give
Mhm.
you 5,
Both of them give you 5.
and 1 times 4 is 4.
9 times 6 is 54. It's really like a magic act, isn't it?
I've got it. I'm scared. Let's not move.
Some kids, some of this stuff, kids say, it feels like cheating. It's too easy.
Yep.
Let's do a
All
couple, another double number. 2 6s, 2 7s, 2 8s.
Okay, I could do it.
Okay.
So we're gonna circle 8,
Double circle on 8s.
double circle on 8, and then go across to 2,
You okay?
and double square that.
Okay.
And then 8 from 2. 2 from 8 is going to be 6.
Okay. There's our tens.
And then 2 times 2 is 4. 64.
8
Wow.
times 8 is 64.
Okay. I'm getting this now.
All right.
All right, how would you do division? You mentioned division.
Well, what you do with division is give me like what would be a flashcard, a division flashcard. So give me a division flashcard.
But both numbers have to be on the left-hand side?
Yeah. The number that you end up with, like say the 64 here. Well, let's do a mixed one. So let's do the 56. And
Number bond.
divide that by what?
Oh, 56 by 8.
8.
Okay, good. So we circle 8. Okay. Now,
Uh-huh.
our diagonal here, our 5, what number are we going to have to go to over here to get our 5?
Wait, say that again. I'm a circle.
8 minus what number is 5?
3. 3.
3. Okay, so let's put our square over, so we get our square over there.
Uh-huh.
Okay, now our 6 over here, what number do we have to multiply 3 times to get 6?
2.
2. Okay, so there's our other square. And then we just go our diagonal going back across this way. And our answer is 7.
Whoa. Okay, wait a minute here. Okay, one more time. So 49.
49
Divided by 7.
divided by 7. Okay, so 7 is going to be one of our numbers, right?
Mm-hmm. Mm-hmm.
Okay. And That's going to point over to 3. So that's going to be one of our squares. Okay. Now,
Okay.
our 4 with 7 minus what number is 4?
Okay, that's 7 minus the 3.
Okay, so then our 3 is our other number. So then that means that it goes right back and it points us right back to make our square because it's all the same number.
Oh, okay, okay.
But I would use it more for multiplication than division. I just wanted to show you that it can be.
Okay, yeah.
Because actually, if you try to divide 48, by 7, it's not going to work because it has to work. It has to fit perfectly. This technique actually works for more numbers than just left to right. There are a few exceptions. So 5, you can see on the black lines, 5 works with 6, 7, 8, 9. Well, that's great. And then next to it are the red lines. 4 works with 7, 8, 9. And then 3 works with 8, 9. And then 2 works with 9. And those are the extra numbers that work. But it's basically the bigger numbers that kids struggle with. So the left numbers, multiplying any 2 left numbers is the big advantage of using this technique. One question, and I actually don't know the answer at this point, and I'm going to sit down and figure it out, is why do the subtractions give you the same answer in cross numbers?
I have no idea.
So if somebody wants something to think about, I'm going to think about that and I will come up with a solution. And I'd like you guys to do that. If you'd like a challenging problem, even you being here today really helps me do that. So thank you for being here.
Thank you.
Yes, thanks for doing this. Absolutely. Appreciate it.
I'm so excited. I got another trick up my sleeve.
All right. Another trick up your sleeve.